Okay, this is 6.5 Law of Cosines video lesson. If you haven't already got out a sheet of notebook paper, you need to go ahead and do that. These notes are going to be on notebook paper. And so let's just jump into an example. Let me explain to you when we would use Law of Cosines. Okay, so I'm going to draw a triangle, and this triangle is not drawn to scale, meaning that it could be a right triangle, it could be isosceles. It's just triangle ABC. We don't know much about it. And just as a review in geometry, across from angle A would be side A, and we use a lowercase letter to represent sides. Across from angle B would be side B, and across from angle C would be side C. Okay, now you saw in the activity what the law of cosines was, and hopefully you wrote these down. So in thinking about a squared would be equal to b squared plus c squared, just like it would be in Pythagorean theorem, except it's minus 2, the product of these two sides, times the cosine of this angle across from side A. And this will work in any combination, meaning that also b squared would be equal to a squared plus c squared. Okay, so it's just like Pythagorean theorem again, except you're going to subtract 2 times, again, the product of a and c, and this time you would use cosine of b. Okay, so why don't you pause the video if you want and try to see if you can write down the c squared one. Okay, hopefully you were able to get it. This kind of gives you an idea of how law of cosines is used. It's used to relate the 3 sides of a triangle to one of the angles. So it's typically useful to find a missing side when you know 2 of the sides in an angle, although if you know all 3 sides, you could also use this to find an angle. Okay, so let's just go ahead and do an example. Let me draw a triangle. And each time I draw these, I am not drawing them to scale. I have no idea if this side really is the shortest side. Typically, this angle will not really be representative as if you put a protractor up to it. And so it's not drawn to scale. And so the directions on this particular problem are to find x, and that's very typical, or to, I may say, find side A or something like that if it's labeled. And so before we continue, I want to know, is this a unique triangle? Meaning, is there only one triangle that has this information? It has these 2 sides and the included angle. The answer to that question is yes. There's triangle congruence theorems, and this one would be SAS. Okay, you did this in geometry. And these are important for a lot of different reasons, not just geometry proofs and all that, but there's only one triangle that has this information. And that means that there is only one answer for x. We will get to some problems in the next lesson where there could be more than one answer or no answer. And so we need to be aware of that. And I'm just going to kind of put it in there as it comes up. All right, so let's think about how we would use law of cosines. So I'm trying to find x. I'm going to go ahead and write this as x squared. The other reason that I'm putting x by itself is because the angle that I know is opposite of x. That's really the true reason. So x squared is going to be equal to 388 squared plus 212 squared minus 2 times the product of the 2 sides that we know, times cosine of the angle that we know. And always when you're working these kinds of problems, you want to make sure that the angle that you're taking cosine of is opposite of the side that's over here by itself. It's not the hypotenuse, but it is somewhat like the hypotenuse from before when we did just regular Pythagorean theorem. Okay, so this seems complicated, but really your calculator will do this work for you. So first what we're going to do is we're going to type in all of this just in one line, and then we're going to square root it. And I'm going to go ahead and write the approximation symbol because we are going to get a decimal that we're going to have to round. And everything that I'm doing here is calculator, So you would definitely get a calculator on a test or a quiz or something like that. Okay, let me wake up my calculator. Here we go. Okay, so we have 388 squared plus 212 squared minus 2 times 388 times 212 times the cosine, and let me make sure I'm in, this is degrees, I can tell because of the degree symbol, make sure you're in the right mode, of 82.4. Now what I'm finding here is x squared, so I need to square root my answer, and I could have actually put a square root symbol at the very beginning of this and just done this in one step. So that's 416.8096 rounded to 3 decimal places. This is 416.81. So there we approximated x. There is no way without technology to do this except to write a statement that may be true, but to get an actual number you're going to have to use a calculator. Okay, so that was SAS. That's a way to use law of cosines. All right, let's do another example. So let's say this time I'm going to label this triangle X, Y, and Z. And side Y is 8, side X is 5, and side Z is 12. Okay, which triangle congruence postulate states that this is a unique triangle, that there's only one triangle with this information? That would be SSS. Okay, and we're going to use law of cosines on this type of triangle as well. And in this case, the directions are just going to be to find the angles. And we're going to actually find all of them. Now, how many times do you think we're going to have to use Pythagorean theorem? How many times do you think we're going to have to use law of cosines? Do you think we're going to have to use it 3 times? We could, or we could use it twice and then use what we know about the 3 angles of a triangle. How much do the 3 angles of a triangle add up to? 180. So once we find 2 angles, we can find the third one pretty easily. Okay, so it doesn't really matter which one you start with. Let's start with finding angle X. So that means that I would start with 5 squared, and 5 squared would be equal to 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of X, angle X. Okay, now you've got to use good algebra skills here. This is not as simple as just typing it all in at once. And you don't want to lose accuracy as you go along. Okay, so what I'm going to do is I'm going to isolate the cosine X and then type it in the calculator. So first thing I would want to do is I would want to subtract the 8 squared and the 12 squared. So I would have 5 squared minus 8 squared minus 12 squared, and that's going to be equal to negative 2 times 8 times 12 times cosine X. And then I would want to divide. Okay, so I'm going to divide by this negative 2 times 8 times 12. Okay, and that's going to equal cosine X. So then angle X, the measure of angle X, is going to equal to arc cosine of this whole thing. 5 squared minus 8 squared minus 12 squared over negative 2 times 8 times 12. Okay, you could do it step by step, or you could do it this way, or, you have to use good algebra skills no matter what you do. Alright, so let's type this in. Arc cosine. I'm in degrees mode, which is good. And so I'm going to make sure, though, that I type this in right by adding in the numerator in its own set of parentheses. So 5 squared minus 8 squared minus 12 squared divided by negative 2 times 8 times 12. and I get 17.612 degrees. There we go. There's the first angle. And now all we have to do is a very similar process to find angle y. Okay, so in finding angle y, you may not want to go back up to the very beginning. If you're able to just think about what measure of angle y will be in terms of arc cosine, that might be helpful. So think about, so across from y was the 8, so here we would start with 8 squared minus 5 squared minus 12 squared. And then in the denominator, we would have negative 2 times 5 times 12. And I'll show you why I really like this method, is because when I go into my calculator, I don't really have to type in that whole thing again. I can just come up here and just change what I want to change. So that would change to an 8. That would change to a 5. And then this 8 down here would change to a 5. It's kind of nice and convenient. So here for angle y, we get 28.955 degrees. Okay, so there's second angle. Then again for the third angle, there's no need in doing law of cosines again. You should just add these two up, subtract it from 180, and you get your third angle as 133.433 degrees. And you want to be accurate to 3 decimal places unless the directions tell you to do something else. Okay, so that's pretty much it for law of cosines. There's one more thing though I want to show you, and that is how to find area of a triangle. You have, for area of a triangle, you have another formula that you've used for many years. A equals 1/2 BH, and here B and H stand for base and height. So if you know the base and you find the height, then you can find the area of a triangle. But in many times you don't know the height. You know the base or one other side and maybe an angle, maybe another side. So I'm going to give you a new formula that you can use, and this is going to be very useful. And this is A equals 1/2 BC sine of A. Okay, so let me draw this triangle and show you how this would be useful. Let's say you were given B and you were given C and you knew these two sides. So side A would be here. That means angle A would be the included angle. This is an SAS triangle, so there's only one triangle. This is a unique triangle. You can find the area of this triangle based on this information. Okay, so I want you to find the area of triangle XYZ, which is from problem number 2. Okay, so let's sneak back, and for you it's probably just right above. And so we could pick any angle that we wanted, and when I used to teach this in class, I would have different groups find it differently, and we'd all end up with the same area. So let's just use, since this was the first angle that we came up with, let's just go ahead and use this this angle. So if we use angle X, then we would have to be using 8 and 12 as our two sides. So I would have area equals 1/2 8 times 12 times sine of 17.612 degrees. And then again, this is an approximation. So let's go into our calculator. So I'm gonna use 0.5. I don't know why, I always liked using that instead. You can use a times sign, or you can use the parentheses. Now, by typing in 17.612 and not the actual number that it was, I've lost a little bit of accuracy. Oh, I'm sorry. That was not 5 times 8. Probably all of you caught that. I caught it, but just a little bit too late. It should be 8 and 12. It's really important because that will mess up your answer. So sine of 17.612. This is another reason why you always want to show your work on a quiz or a test, because if you make that mistake, then I can catch it. All right, so 14.523. Now, if I were to actually use the 17.61 whatever number, I could be off by as much as 1,000th. If we were doing this problem on a quiz or a test and we were going through this, you would want to try to stay as accurate as possible, but I want to show you how we actually are off by 1,000th. If I do the second iter thing and I go back to how I got the 17 number in the first place, and instead of doing, and now if I do the area formula, let me show you what happens. Instead of hitting 17.612, if I hit second answer, I'll show you what happens. So we were actually thinking that our answer was 14.523, but it was really 14.524. Now, this is important. If this was your job, you would want to be completely accurate. Now, on a quiz or a test of mine, if I were to have you do this several times, I would expect you to be accurate, but I don't want this to be a point of stress for anybody. And since there were no units, I'm going to go ahead and put units squared here, just the word units squared. So try to be as accurate as you can be. This is always the goal, but don't get stressed out about this one thing. Okay,